Assalamualaikum and hi everyone. My name is Hazwani binti Muhammad Yusuf. This video is for my group project together with my partner Haidah binti Razali, and we choose for the metal is the aluminium, and this is for our subject metallurgy. So, what is meant by aluminium? Aluminium is actually a silvery white metal from the element of group 13 in the periodic table, and they have an atomic number of 13 with the melting point around 600 to 700 degrees Celsius, and it has a boiling point around 2500 to 2600 degrees Celsius. For the introduction, I will explain for three things, which are the background of alumina, the brief insight properties of aluminium, and the aluminium matrix composites. So firstly is the background of alumina. Aluminium is actually a good electrical conductor and is often used in the electrical transmission lines. And we discover it in the early of 19th century in an impure form before the discovery of the method to obtain the pure aluminium. So, from the figure that is stated in the slide, there is the structure of the aluminium alloys with different reinforcements. Next is the brief insight properties of aluminium. So, it is actually very rare to find as pure since it is usually combined with other minerals such as the bauxite and the chrolite. So, this happened due to its highly reactivity and readily compounds with other materials. So, for approximation, around 15 megawatt per ton of output, which is about as much as 100 apartment blocks consumed in a month, was taken for the production of aluminium, which is quite expensive. However, it can be recycled since aluminium is very hard corrosive material. Next is the aluminium matrix composites. It is readily forms alloy with silicon, copper, zinc, magnesium, and manganese. Currently, a lot of metals that are called aluminium alloys, which is the foil, typically 92 until 99% aluminium alloy. So, to enhance or modify the characteristics like the stiffness, the strength, and the thermal conductivity, and so on, metals will be reinforced with the fibers or particles to create the metal matrix composites, which is normally known as MMCs. So, aluminium alloy is one of the matrix composites made up of three parts, which are the matrix, the reinforcement, and the interface that connects those two. So from the slide below, we can see the structure of the aluminium. There are two pictures. So the first picture is the atomic structure of the aluminium. So the group 13 of the periodic table contains the metal of aluminium with atomic number of 13. And it has an atomic weight of 26.982 and has density of 2.7. The melting temperature of the aluminium is 660 degrees Celsius, and it has an atomic radius of 0.143 nanometer. And aluminium is except for a few high temperature monovalent and divalent gaseous species. The aluminium atom has an electronic configuration of 1s2, 2s2, 2p6, 3s2, and 3p1, and has a valence electron of 3 in all compounds. So the next picture, the second picture, is the crystal structure of the pure aluminium, that it has a face-centered cubic crystal structure, usually known as the FCC. And it will be a closed pack arrangement with a single atom as its base at room temperature. So in this topic, we will explain for the three main processing for the aluminium. Firstly is the stir casting, secondly is the powder metallurgy, and thirdly is the friction stir processing known as FSP. So for the stir casting, we can see that the below in the slide is the figure for the stir casting. It is actually blends molten metal with reinforcement particles through continuous stirring using a high shear impeller, creating a vortex. So the exposure of the metal surface to the atmosphere enhances wetting characteristics, so it makes it suitable for adding reinforcement. So the mixed material is then put into a mold. So next, for the powder metallurgy, it will be has crushing, atomization, or chemical reactions to obtain the aluminum powder. So it mixing combines metal powders for the desired alloy composition while blending groups of similar particles. Next, we will compact the shapes the mixed powder using the methods like cold die compaction or isostatic pressing. The last process will be the sintering, a heat treatment to form solid parts with desired properties by creating a permanent bond between metal particles. Lastly is the friction stir processing. It refines metallic materials without changing their state. A non-consumable tool with a cylinder and pin stirs and moves along the material. It then will generate a heat through the friction. So this will localize the heating, soften the material, and causing significant plastic deformation and grain refinement. So through this process, it will involve the mixing the base material with a second material to alter the microstructure while keeping the physical state unchanged. Next, for the properties of aluminium, there are two properties, which are the physical properties and the chemical properties. So for the physical properties, we will focus on the high durability, high reflectivity, poor heat absorption capacity, and aluminium is also can be recycled easily, and aluminium is very extremely high strength to weight ratio. Next, for the chemical properties, we will focus on two things. That the aluminium is actually a high corrosion resistance, lower in alloy form. So, as we know, the corrosion is involving the oxidation, the air. So, the aluminium is very high corrosion resistance. Next is the reactive with hot acids and sodium hydroxide. Lastly is for the application of the aluminium, where aluminium will usually be used. Firstly, we will usually seen in the transportation, space and defense, for the security, food also, communication, aeronautics, healthcare, sports and leisure, and energy, and lastly for the home automation. So, in this topic, we will focus on the automotive and aerospace industries, as it makes extensive use of composites made from aluminium matrix due to the characteristic of the aluminium, such as the superior strength, for the wear-rated properties, as aluminium is also lighter weight, and lastly, it is excellent in fuel efficiency. And aluminium also finds extensive application in the transportation, as I said just now. And metal fuel for energetic materials is aluminium, which has a high calorific value and large supply. Lastly, it is usually being used in the automotive body structure, electronic technology, wind and solar energy management, and lastly, electric module packaging industry. So, lastly, these are the references from our topics that we used to make these slides. That's all from me and with my partner, Haidah. Thank you.